So in the last lesson, you learned how to convert between mass or particles or moles or liters of one substance in order to then predict how much of a product would be formed. And so the issue, though, is it's really nice and easy if you know I have this amount of reactant, then I can figure out how much product forms. Well, the issue is, what if I have two different amounts of reactant? How do I figure out how much of my product is going to form? Well, in order to explain this concept is called limiting reactants. And in order to explain it, I'm going to use a real life example. I'm going to talk about s'mores. So the first thing that we're going to do is just make sure we're okay with particle diagrams. Okay? So what I'm going to do really quickly, to make a s'more, you need 2 rectangles of chocolate, you need 1 marshmallow, and you need 2 graham crackers. So to write the chemical reaction, my product I've already written for you because they're bound together. You have CH2, MM1G2. Fine. That looks great. Now, for your reactants, when I make a s'more, I like my chocolates attached. So I'm going to have CH2 because they're attached to each other. If it was 2CH, they would be separate. I'm going to have 1 marshmallow. And then my graham crackers have to be separated or else it wouldn't be a s'more. And so it's going to be 2 graham crackers. So what I want you to do really quickly before you get going with the problems is I want you to draw the particle diagram for these 3 reactants becoming a s'more. Alright, so let's look at some calculations for this. So if I tell you I have 2 rectangles of chocolate, how many s'mores can I make? Well, because you need 2 rectangles of chocolate for each s'more, it's going to be 1 s'more. If I have 4 graham crackers, that would make 2 s'mores. And then if I have 6 marshmallows, that would be 6. So I have all of these different possibilities, but the important thing for you to know is that I can only make 1 s'more. And the reason why is because I don't have enough chocolate. So excess reactants, how much is unused? Well, for the rectangles of chocolate, there's nothing that's left over. For the graham crackers, I only used 2 to make that 1 s'more, so I'm going to have 2 graham crackers left over. And then because I only made 1 s'more, I'm going to have 5 marshmallows left over. And so the ingredient that's used up, your limiting reactant, that is going to be your rectangles of chocolate. Okay? So we're now going to take this concept and we're going to apply it to chemistry. So if we look at this problem, I tell you you have 2.5 moles of copper and 5.5 moles of silver nitrate. Those are your 2 reactants. How many moles of silver can be produced? Well, just like with this s'more example where I had you determine how many s'mores each of the reactants would make, we've got to figure out how many moles of silver each of those reactants will produce. And so I'm going to take my givens and I'm going to convert. But the first thing I've got to do is balance. So I'm going to put a 2 in front of AgNO3 and a 2 in front of Ag. So let's actually get going. So my given is 2.5 moles of copper. And so I'm going to convert that into moles of silver. So I'm going to put moles of copper on bottom, moles of silver up top. I'm going to use the mole to mole ratio. So I've got 2 moles of silver for every 1 mole of copper. And so that gives me 5.0 moles of Ag. So 2.5 moles of copper will produce 5.0 moles of silver. My other reactant, which is 5.5 moles of silver nitrate, I'm going to convert. I'm going to put moles of silver nitrate on bottom, moles of silver up top. Okay, there are 2 moles of silver nitrate for every 2 moles of silver. And so I find that 5.5 moles of silver nitrate will produce 5.5 moles of Ag. So one produces 5 moles of silver, one produces 5.5. So how many moles are actually produced? 5, just like with the s'more example. Now, what would my limiting reactant be? That would be the reactant that dictates how much product I can make. So copper is your limiting reactant because once you've made 5.0 moles of silver, you run out of copper and you can't make any more. Even though there's enough silver nitrate to make 5.5 moles of silver, there's not enough copper, making copper your limiting reactant. So let's look at another example. I give you this reaction with copper and sulfur. I tell you how much copper and sulfur you have, and I ask how many grams of copper 1 sulfide would be produced. Well, the first thing I've got to do is balance, so I'm going to put a 2 in front of copper. Then I'm going to take my given, so I'm going to take 80 grams of copper, and I'm going to convert that into grams of copper sulfide, just like what you did in the last lesson. So I'm going to put grams of copper on bottom, moles of copper up top. So I'm going to put the molar mass of copper on bottom, 1 for moles of copper. Now I need to get into moles of copper 1 sulfide. So I'm going to put moles of copper on bottom, moles of copper 1 sulfide on top. I'm going to put the coefficients, so I've got a 1 for copper 1 sulfide and a 2 for copper. Then I'm going to get into grams of copper 1 sulfide. So I'm going to put moles on bottom, grams up top. The molar mass of copper 1 sulfide is 159.17 for every 1 mole of copper 1 sulfide. And so that will produce, when you do the math, 100 grams of copper sulfide. Awesome. In the last lesson, you would have been done. But we have another reactant, so we need to figure out which of those reactants produces the least amount of product. So I've got 25.0 grams of sulfur. I'm going to convert into moles of sulfur, put the molar mass of sulfur. Then I'm going to get into moles of copper 1 sulfide, so moles of sulfur on bottom, moles of copper 1 sulfide up top, 1 and 1 for your mole-to-mole ratio. Then I'm going to put moles of copper 1 sulfide on bottom, grams up top, molar mass of copper 1 sulfide, and then 1. And that produces 124 grams, which tells me that only 100 grams of copper 1 sulfide can be produced, because after that, all of the copper is gone, meaning copper is your limiting reactant. Okay, and there's excess sulfur. Okay. The last concept that we're going to talk about is your percent yield. Now, your percent yield lets experimenters know the degree of success with which they were able to create a product. So what exactly does that mean? Well, your percent yield is your actual, so what you actually got in the lab, divided by your theoretical, which is what we have been calculating so far. That is what, when you calculate it, that's what you should get. So actual in the lab, theoretical on paper, times 100%. So in this problem, your actual yield is 18.5. Your theoretical is 24.8. So I'm going to take 18.5, divide by 24.8, and multiply by 100. And so I get 74.6%. Okay, so in this lesson, you learned how to determine your limiting reactant, determine your theoretical yield, that's what we did before, and now how to calculate your percent yields.